And we have to protect the wee precious children.
What about the children?
Alright, we're at a kilovolt and change.
What are you gonna do?
Everyone back the hell up.
3, 2. Hang on a minute. 3, 2.
Holy crap, man.
That was a good what? That fired faster.
We're going to 1500 volts.
Yeah, you're there.
1500 volts in 3,
Jesus.
2. At 1500, we tap the ceiling.
Yeah.
2 kilovolts. 3, 2.
Okay.
Yeah, that definitely hits the ceiling. 2 kilovolts. 3, 2. 3, 2. That is so freaking cool. 2500 volts in 3, 2. 2 kilovolts in 3, 2. That was aluminum.
Yeah. I'll just stand behind you. Don't stand behind me.
2700 volts out of it. 3, 2. Awesome! That came down as fast as it went up. 27.5 in 3, 2, 1. That's science. 27.5, 1391 indicated in 3, 2. Firing in 3, 2. We'd like to thank our sponsor, Rust-Oleum. That's warm. We'd like to thank our awesome sponsor, Rust-Oleum. 3, 2, 1.
I think they're all metal.
3, 2, 1.
Where'd it go?
Over there. 3, 2.
Oh, I saw it.
Oh, shit.
Not twice.
Almost twice the building.
Yeah, I fought.
3, 2.
Oh, shit.
Oh shit, my car. 3, 2,
Rolling.
1.
Oh.
3, 2, 1. In 3, 2, 1. I'm Chris Boden and welcome to today's Captain's Blog. It is Saturday, September 8th at 12:17 hours, and we're here in the VSL where Batman is going to flip this around. We did the reciprocal assembly yesterday. That was a pretty short video. We just tore into the bottom. We talked about main bearings, and we talked about the crankshaft, and talked about counterweights and connecting rods. Did a lot on connecting rods and pistons, and that was pretty cool. And today we're going to talk about transmissions. We're going to flip that around and just get a quick look inside a manual transmission. So that'll be pretty fun.
Exclusively using that just to get the fancy arty shots. Okay. The word skeleton crew comes to mind, but not the cool kind.
How many people does it take?
One, actually.
Thank you. And that's including the presenter.
What?
I've shot videos by myself.
You You're doing it right now, actually.
No, I mean like Geek Group production videos with the 3-camera shoot. I've done it by myself. It's not easy, but it can be done. You set up a wide shot and the overhead, and those are static, so you don't really have to mess with those.
Yeah.
And then you set up the close-up shot at a fixed point, and I reference it using, I call it the bullet model. I put the camera with the blocking monitor, and then I have a spot behind me on the wall, and I know the camera's pointing at that spot. Like for this, it'd be like pointing at my motorcycle. And I just pretend that there's a bullet going right through me, and I keep myself lined up right there. And then I use that for my close-up. And if I plant my feet, I can always spin right around, be like, boom, and it's always dead on my blocking monitor, and it just works. What have you got? Huh?
Automatic jumper.
That's kind of cool. Where'd it come from?
Laser lab, you just sat on the floor.
Yeah?
Yeah.
Huh.
Complete with the...
We should keep that.
Any particular place?
I'd put it in supply on a top shelf. It'd be a good safe place for it. Thank you, Moose. Moose is back from vacation. Yay! The whole world missed you.
Yeah.
Yeah, that's a thing. And the dog. Dog missed you a lot. Dog is not here today, but we will see the dog in a bit. We're going to be heading over to 7. So, yeah, we're going to get this done. Batman's spinning this around. Batman's half awake.
I had a long conversation with my old man. It just like kind of brought me down a little bit.
This morning?
Yeah.
Oh, okay. You alright?
I'm alright.
Okay. Moose?
What?
Why are there little cat hairs on the truck?
It's not my cat.
There's no cats in the lab. I mean, not since the accident. Jabroni?
Maybe he's shedding.
No, Jabroni sheds a lot, and it is time for him to get his winter coat, but these are little white hairs.
There's been a couple times we've left the door open. A little alley cat will poke his head in here.
We got an alley cat that hangs out?
Yeah.
There's
a little black and white one.
Cool.
He only sheds white
Yesterday,
hairs.
I was coming back from the Geek House 5. I've never seen a cat jump out of a tree before. It scared me. I was walking along and like 6 feet in front of me.
Now he's living in fear.
I know cats climb
Ninja
trees.
cats.
I just don't usually think of them as
You
dropping
just always
from
assume
trees.
firemen got them out. It was always a
No, I
one-way
assumed they
ticket.
climbed down like civilized creatures.
Has anybody ever seen Jabroni descend the fire escape ladder? You don't climb down. You just... with your mad, smooth ninja skills that you have.
Jabroni has never at any point claimed to be civilized.
Okay, well, there is that. He's a high-class mofo. And I think he just came a little or something there. What was the... I don't want to know.
My neck is all screwed up, but then if I crack it, it feels enormously better.
Yeah?
I know how you feel.
Yep.
All right, so what are you doing today?
Making things, cleaning things.
You've got a class with the guy.
Yeah.
You got a CNC class.
At any time.
Okay.
I had the SR on yesterday, so you don't need to do a warm-up on it.
I already did one.
Alright. Alright, I need to be where you guys are.
Oh, hey, people watching. I need a way. I can clean this down. I can get it super clean. That's easy. But I need a way where it can remain clean and yet not rust. I want to make it into a display, and I don't want to have it covered in oil or grease, but I still want it to not rust. And I'm pretty sure not everything in there is aluminum. Well, I can't do a clear coat because
You want it to run still.
I want it to move. Yeah, I want to have a little electric motor on it and have it just do its thing. So I need you to save any parts of the reciprocal assembly. Okay? Like pistons, connecting rods, bearings. I took some of that apart, so I'll point them out to you when we do the cleanup, okay? Alright, you guys have fun. We'll be back.
10 minutes then?
I'm going to be here for a while, so I'd like to see if we can actually fire this thing today.
I would dearly love it if we could get this to operational testing today, even low power stuff. Yeah. We got all the parts, we got the right brain power, we got CAD, we got slide rules, we got everything we need.
Old versus new.
We need Cyril to help us.
Grab him. He's downstairs.
No, actually, Cyril needs to help Aaron.
I never actually learned his name.
Cyril.
I know. I've been calling him the Dutchman because he wouldn't tell me his name.
Cyril.
which is a very odd thing to do to give that person.
No, it's not cereal. It's not Cyril. It's Cyril. Cyril. Two syllables. Cyril.
It works for me.
Say Cyril and have somebody punch you in the neck when you do. That's how you pronounce it, right? Yeah.
No, I ain't doing that. Okay. Yeah. Well.
So I'm gonna stop standing around and get to work. So.
All right, you get to work. I've got to get a crew over to 7 and start rocking on stuff there. I'm gonna do that after lunch. We'll be back.
There's a lot more lewd over here.
Huh?
It looks a lot more lewd over there.
Oh, okay. Well, look. It does look quite lewd. This has been the worst video series ever. It's kicking my ass.
Like brick wall after brick wall. Right?
Well, the problem with this, it's stuff I actually know, but I don't know this specific, so there's these little things that keep tripping me up, and I'm like, I'm this close to saying, just fuck it, shit can the whole series.
Hulk smash it.
Yeah, just let Batman take it. The entire Autopsy video series of this will just be 30 seconds of this thing running through the shredder at Padnos. There, look, you can see inside now. Look at all the little parts. See that? Those are gears. Fuck gears. Huh? All right, I'll move my car.
Out at Forge Creek. They could have left her in Opelousas. They could have left her in New Orleans. But they brought her home with them.
They brought her home with them. When we left New Orleans. What you got, Moose?
I need you to come look at this.
Huh?
I need you to come look at this.
What?
I have a pile of debris and I don't know what you need or what you don't.
Oh, okay.
Hey, Batman? Dave could really use a second hand for a moment.
What do you need me to identify?
This stuff.
What stuff?
What are you done using and what is still going to be used?
It's all, I'm done with everything. It's all copper stock. It all goes into material stock.
Okay.
Cool. See how easy that was? 10 minutes to lunch and I'm starving.
Here up through this hole.
But
Then
both?
it's going to come up here, or actually it's going to, yeah, it's going to come up right through here and lock on here. The second one comes up, or is this other cable here already, comes up, laces around the resistors, and then jumps up here. That's...
But two wires have to go down to the bottom for the
Yep.
discharge. And you gotta know where they go. Go pick up your...
This is where this...
Oh, so you already have a...
Yeah. So the wires that I just described are him and him.
Right.
So, and then it goes...
Hang on.
This is so
Which
confusing.
two?
I know.
Which two? What you making, Bruce?
It's a voltage divider.
Yeah.
Using crappy off-the-shelf film resistors, and it'll work. Oops.
So what is a voltage divider? What
Huh?
does it do? Teach people stuff.
What?
You're teaching stuff.
I mean, you put voltage on one end and you get a representation of the voltage on the other end. You take a potentiometer can be a voltage divider. Two resistors can be a voltage divider. Your finger and a cold water pipe can be a voltage divider. Your tongue and a What is that? Cold flagpole could be a voltage divider. Yeah.
We'll test that one in the winter. We'll find like cricket and we'll hook him up.
Yeah, cricket will do it too.
Would he? Okay, we're gonna put 4 kV on one end. We're gonna get 4 volts out the other.
Awesome, man.
So we're gonna drop some voltage across a bunch of resistors and end up with a smaller voltage where we want it. And hopefully the voltage won't jump. And
Okay.
yeah. Excuse me, pardon me. Your phone's ringing.
Frank's calling. What's up? I'm at the Geek Group.
We have viewer mail from, it's Royal Mail, so it's from England. Doesn't say where, doesn't say who. I think it's a flag. It looks like a Union flag, but it's got pink on it. Dave! What is this?
I'm gonna go with maybe breast cancer awareness.
Maybe? I don't know. I've seen American flags done in different color schemes, but I have somebody's got to tell me on this one, guys. I don't know. It's a Union flag with pink. You got to figure this one out for me. Is this for like UK girls or something?
Yeah, because the other one's for boys is blue.
Oh.
Yeah.
Cool. That UK girls rock. They finally sent in a flag. Oh, hey, what do we got?
According to the first Google result, it's a gay pride.
Oh, it's gay pride. Yes! Totally cool. Okay. I still prefer UK girls, but we have a UK gay pride flag. In the US, they do the same thing, only they do the stripes in rainbow colors. So, cool. Thank you. The Geek Group strongly supports LGBT rights. You guys rock. We will hang this proudly. Cool, the UK pride flag.
Most, yeah, German letter is used. Yeah. Yeah.
I like ladder.
Watch out for those guys over at Siemens. They might work with the CIA.
Hey,
Oh, yeah.
you got to tell them who you are and why you're here and what you do and what you're working on and all kinds of stuff.
I'm Seru from the Netherlands, and I'm working on an electric trike project for a disabled kid, which is over there.
It's the pink one behind the saw.
There's a 12-volt DC motor, which we are going to be variable speed control with an Arduino.
For blog cred.
Yeah, PWM control with potentiometer and some BP MOSFETs. Yeah.
So you're from the Netherlands.
I'm from the Netherlands.
You came here
Came
to
here.
the Geek Group.
Yeah.
You got to tell them your story. How'd you find out about the Geek Group?
I discovered about 6 months ago.
Okay.
It's on YouTube.
So just you found us through the videos?
Yeah.
Okay.
And start watching the videos and always wanted to go to America sometimes. And this was a great,
Okay.
a great way to go to America.
So we're your excuse to come check out the States?
Yeah.
Okay. So you've been here a few days.
Yeah.
What do you think of it so far?
Nice.
Yeah?
The Gemini is loud.
Have you
Come
seen
here.
Thumper yet?
No.
Thumper's even louder.
Yeah.
Yeah.
You can even hear it in the basement.
Oh yeah.
Yeah.
Once you start to get an ear for it, you'll notice it out here when they fire Thumper. You'll definitely hear it out here.
You hear the buzzer and then boom.
Yep. So you're working on a motor controller.
Yeah.
So you took the MOSFETs from this.
Yeah, from an old. I guess it's a good servo control.
Okay.
Which.
So these are the
doesn't-
MOSFETs.
Yeah, the MOSFETs were okay, but the board was not okay anymore.
Okay. And you're putting them on this?
No, I'll probably just use a bit of board.
Okay.
And we're gonna put potentiometer going to be.
So that'll be the speed control. We got to rig that to the foot pedal. Okay.
Figure it out some way. Yeah, I'd probably use an example project.
Okay.
Real simple.
Yeah, it's just a motor driver, so it's pretty simple. Are you doing this with an H-bridge or?
Yeah, do you want reverse?
Yeah, they need reverse.
Okay, yeah, probably or relays for reverse.
Do that. Well, those are kind of small, but
yeah, get some beefy relays.
Okay.
Just switch the.
Okay. Cool. Yeah, I'm gonna let you rock out. I get out of your hair. I'll come bug Bill. Hi, Bill.
What's up?
What are you doing, Bill?
Finishing up the wiring.
Still?
Yeah. Takes time to get it right.
Yeah, this is like your 4th time.
No, this is I only screwed up one of the jumps.
Okay.
Made it a little too long, but they're nice and tight.
Can you do
want
that?
this mounted on the outside? Or
No,
would you like it
this will
inserted
be on the inside. It'll be on the inside.
1 voltmeter goes there.
Well,
Another
about
voltmeter
there.
goes there.
Okay.
One's going to display voltage and one's going to display kilojoules.
Well, joules. It'll be kilojoules when there's 4 numbers.
How about watt seconds?
Okay, that'll be cool.
I just realized I now need to take that apart.
Yay!
I still have to drill those 2 holes for the control lines.
Okay. If
Somebody said they drill the steel ones for me.
I'll drill the steel ones for you. Pop the plate off. I'll drill them.
I'm gonna do that.
All right.
It takes 2 people.
Why you fronting, man?
Because I gotta.
Okay. You gotta get pants that fit.
No.
You do.
I kind of like the idea of walking around in dumb waiters. It's practice.
I think you mean hip waiters, not dumb waiters.
What's a dumb waiter? Is it a different thing?
A dumb waiter is a little elevator that carries shit up and down.
I'd like to ride in one of those too. Those are fun.
We almost had a dumb waiter. We very nearly did. Before we bought this building, we were looking at another one way the hell across town, and it had a dumb waiter. In fact, there's even video of this camera riding in the dumb waiter.
Well, there's the resistor stage.
Okay.
So
that's a damn fine resistor system you've got there, boy.
thank you. So nice, big.
I'm quite proud of you.
So now I gotta have the 2 control cables. I think they'll come down offset center.
Right here. That means we gotta take all this shit apart.
Yep. Well,
Right.
you know, gotta drill these holes first. Probably.
Well, we don't have to take it all apart. We can leave these connected and everything. We just gotta disconnect that, slide it off.
Yeah.
Yeah, nothing to it. Pop it off.
Now it's nice and true again.
What'd you do there?
I had Moose put it in the lathe,
Yeah.
so now it's perfectly round again. We had a big chunk out of it or whatever.
It like spun in the
yeah.
drill? Yeah. Alright.
So now it's true again.
Cool. What you up to, sir?
They started to cut the cavity on this table leg and making some good progress today.
So you're making a mold for casting aluminum?
Yes, sir.
Cool. That is a big-ass piece of steel.
Yes, it is. It takes a couple of us to build up there.
That's cool. I wish this guy Rick was here. If he was here, they'd be like, because he used to freak with the speeds and feeds. This is us when we do it our way. What you making, Moose?
A table?
Making a table?
Yeah.
Is this a from scratch table?
Well, I didn't turn these if that's what you're asking.
Oh, okay.
I'm doing some product testing for Waddell,
Oh, okay.
and they sent me a table kit.
Oh, okay.
Pretty cool.
It's a table kit.
Yeah, I'm having fun.
Okay. Where are you at? What's going on?
Making up the schematic. Wiring.
Okay.
Little test motor.
It's a cute little test motor.
Did the wiring on the MOSFETs.
Okay.
This will be the wires to the motor. This is part of the. Just like this.
Okay. Cool. Bill's doing control circuitry. Everything in here is high voltage insulated cable. That is not coax, even though it might look like it. This is high voltage insulated cable. And these are the control lines. They only carry 120 volts up here for the control circuitry, but they have to pass through a forest of things bristling at 4 kilovolts down here. So we just used high voltage cable for everything. And it goes down there to where the power board will be. The power board, which is being built by Bruce, who just walked away because I brought out a camera. So yeah, here's the board, which is naked again for the 4th time. So it's getting there.
You know, it's just like many things. Sometimes you got to do it over and over to get it right.
Story of my life. Time is 18:16 hours. We've got the main control circuitry in. Goes all the way down. Power feeds in. We're getting ready to put the top back on it. Bruce has stuff going on.
Everything except wires.
Yeah.
And electricity.
We're actually reusing parts off of the original Geek 3 control board. We're going to reuse some of the circuit breakers for this. You going to Zom?
Getting ready to do some.
So Dave, what's up tonight for Zom?
Outdoor Cascade Park, brains, usual.
You're bringing the Dutchman?
Yep.
Cool. Does it work yet? Oh, hey, look at that.
I didn't even put code in it yet. There's some code in it. That's not PRM yet. I have to do the code thing myself.
Cool.
It's getting there.
It's a start. Yeah, it might even work tomorrow. Who knows? Bill, what's the odds that we launch a ring tonight?
Pretty good.
Pretty good.
Just remember, protect them.
Yeah, we'll do this outside. This outdoor toy. It's on wheels.
Okay.
It's on wheels. Okay. Outside toys. That we take it to the high voltage
just
lab
had to
and make
make
a
sure.
hell of a noise.
Right.
Whang! Oh god, that would suck.
Yeah, I'd be hyped on that one.
Alright. And if we're taking this out for testing, we may have to take that out and just have some fun with it. Just
Yeah, I gotta move my car. It's already had enough damage this week.
And I'm totally not going to miss that like I did the other day while I was sitting inside.
Yeah, I'll even
How
put
did you not
Jabroni on the
hear
roof
it?
again. Yeah, how do you
It
not?
sounds like a bomb going off.
I fell asleep.
Alright, I'm heading to dinner. I'll be back.
Here at the Geek Group, we've invented a new fundraising strategy. You can now purchase impressively tiny coins we've compressed using high-energy magnetism. We induce a current pulse of 100,000 amps into a copper wire coiled around a golden dollar, dime, or quarter, producing very powerful opposing magnetic fields that compress a quarter to the diameter of a dime, which you then receive in a lovely commemorative package along with the satisfaction that can only come from helping the Geek Group build our endowment, which in turn will allow us to put membership fees, donations, and sponsorships towards furthering the organization rather than just maintaining it. Carry a lightning bolt in your pocket, available at thegeekgroup.org.
My plan...
No, why don't we charge
for the
discharge
dump thing?
without a ring?
Oh, well, no, like to fire it without a ring or discharge it through the dump
We should be able to fire without a ring, correct?
No.
Why not?
That can be bad. The ring absorbs a lot of energy. You want to get rid of that energy.
It's not like
we could have a tethered
ring. It's not like pumping. Correct. It's not like pumping it into a coil and expecting it to ring.
Yeah.
The back EMF is going to go bang, and then it's going to say, "Oh, I got extra voltage." It's going to bang back in the coil.
We want to get rid of that energy. We don't want to just crash that into the capacitors.
Yes, I agree.
So here's where we are, and it's quite awesome. You want to break this down for people?
120 volts comes in here. We have a meter. We have a high voltage divider.
All right. So we got.
Okay, let's try.
I'll break this down. You know, you wire stuff.
Just show them this.
We can't show them the secret classified documents. We can't let people actually understand how this works. It's totally secret. It's classified.
I think that's the best thing to do, is just to show them the drawings and they can figure it out on their own.
Totally classified. Nobody can know how to do this because then people could build these at home and that would be dangerous.
In their garage.
And we have to protect the wee precious children.
What about the children?
So, all right, here's what we got.
Don't distract him. He's wiring, man.
I know he's doing stuff with things.
Need better lighting.
Yeah, tell me about it. What I need to do, because we can't afford to do it, we've got to reach out to the members on it, is we're going to replace those lights up there are what we want to use to replace all of those crappy lights.
Oh, some of those nice...
Yeah. but they cost $100 a pop, and we've got 15 of them in here to replace.
And
so
they're
yeah,
cool white.
Yeah,
they're
so much better. Yeah, the color and they don't flicker on video, so they work way better.
That would be nice.
Yeah,
maybe next year.
Well, no, what I gotta do is get those on the Amazon list. It's one of 10,000 things we have to do around here that I just haven't gotten around to. So, all right. This is all controlled circuitry for controlling the relays, or for controlling the switching around and stuff. But here, I'll go through the basic parts. This is a microwave oven transformer. It's feeding into a microwave oven diode, or a capacitor and diode. And this diode, I don't know where the hell that came from, but it just magically appeared. That might be a microwave oven diode. But combined, this gives us a is this a doubler or tripler? As we've got it set up. It's a doubler.
Full wave doubler.
Okay, it's a full wave doubler. High voltage comes out here between here and ground. Cool. These give us our doubler, and the high voltage goes off when the charge thing is hit. The high voltage goes off to the big capacitors over there, current limited through the resistor ring around the caps. This is our voltage divider, which is a couple of beautiful strings of resistors, and this reads at 1,000 to 1, so we're actually feeding 0 to 4 volts into the meter here. And we've got max of 4,000 out. Boop.
For the other
here.
side of the voltage divider. The voltage divider goes right across the capacitor bank.
So here's the main input breaker.
Right now.
This is when we discharge the big giant discharge contactor right there. Is the big discharge contactor. Is 120 volts DC, so we bring our 120 AC into here. This is a full wave bridge rectifier, this little thing. Very handy little job. And you put our AC in there, we get DC out here, but we don't get 120 volts out, we actually get like 140 or so. It's because of the RMS rise. These are contact strips on nice DIN rail, Euro style, because we're cool like that. And yeah, that's the basics of it. Anybody who understands electronics can simply look at this, and you can probably work out the schematic pretty easily. It's rock simple.
That's right. A couple ways.
So there, you can pause the video and you can build one of these power supplies yourself. It's an excellent, the same simple system we use here is what we use for portable thumper, big thumper. It's all based on the same basic concept of starting with a microwave oven power supply and a doubler. Though I think on Stomper we use a tripler. Now the control side of things is also rock simple. There's just 3 buttons. There's an e-stop. Now when this is down, the capacitor bank is tied through 2 contactors to the resistors, so that dumps it safely, and they stay dumped all the time. It just crowbars it. When we want to use it, to turn it on, you spin that and it pops up. Here, I'll show you from the side. If you spin that, it pops up. So that takes us out of discharge mode and arms the system. You press the red button to charge, and these labels will change. These are just this is repurposed from an old conveyor system. But that's the charge button. And you watch the voltage on the meter, and when the voltage is up to 4,000 volts, or wherever you want it to be, you let go and it stops charging and holds it there. When you want to discharge, you press the green button. Green means go, G0, boom, and we're off. And when you press that button, this trips, and it goes chunk, like that. And when that goes chunk, it connects the capacitors through very big wire, through the thing, up here to this, not quite as big wire. This is 4 gauge, and this is, you can actually see the coil through the acrylic there, and the coil is designed to fit a hard drive platen. It'll fit both sides, or both sizes. This is the big size of hard drive platen, and now here's what's actually happening. We've got a whole bunch of electrical energy stored in here. When we dump all that energy through the contactor, through the coil, that energy rushes in and goes, right? Well, that big electrical impulse in this coil creates a really big electromagnetic field. And think of it as a single shot of a Tesla coil, okay? We could actually make a single shot Tesla coil. That'd be kind of cool. I hadn't thought of that till just now. But it creates a big electromagnetic pulse. The electrical energy creates electromagnetic field around it, and that electromagnetic field expands and then collapses very fast. Just okay, and it happens in the blink of an eye. Well, if you just had a coil here, that's all that happened. But if you put this, which is a disc of aluminum covered in rust, but aluminum right there, like that, well, now you've created a transformer. there's your primary, and this is your secondary. Think of it as a one-turn secondary. Okay? So, that electromagnetic field encompasses this, and it induces an electrical charge in this ring. Because electricity and magnetism are the same thing. Okay, wherever you have one, you have the other. So this electricity creates an electromagnetic field. That electromagnetic field creates electricity in this ring because they're magnetically coupled. Well, the electrical energy in here creates its own electromagnetic field, and that electromagnetic field opposes this electromagnetic field, so this ring wants to leave very fast. Okay, we're getting into Lenz's law and stuff like that. So this will launch. This will just go wing, and it'll make a ringing noise, and it will levitate. And it won't just levitate like wing. Okay, if we did with like 10 volts, we might maybe just go boop, like that. But with 3,000 joules of energy in there at 4,000 volts, this thing is gone. And it's going to be cool. So, we're almost ready to do first initial low power testing, and we'll see what happens here in a minute. If Bruce ever gets done screwing around, just dragging ass.
I'm just reading from the script.
Yeah? There's a script?
The script says wire A goes to wire G.
Oh, okay.
Attach wire Z to wire...
I'm having him bypass the caps for tonight. We forgot a wire.
We can't bypass the caps.
For the meter
you shouldn't have even said anything.
I know.
No, we're not doing it without a meter.
No, we're doing it with a meter, but we're bypassing the caps direct connection.
You shouldn't even said anything.
Where are we going to connect for...
Look on the drawing.
Okay.
Instead of connecting here, we're going to connect down here.
Why?
Because I want to get this thing to go tonight.
I would have added another
What's the
wire.
difference?
The difference is we take the whole damn thing apart, drill more holes, and put more wires in.
I can drill holes without taking it apart.
We're going to do this
initial
startup.
You're right, Bruce. I shouldn't have said anything.
I told you.
Because
I can drill holes without taking it apart. Wait a minute. I got mad skills, yo!
Don't worry about it.
We're not going to have a strobe light on here. How's that?
I can live with that.
There you go.
You know what you should do?
What?
Is go get your little one from the front, and we should launch that one and see how far that goes, and then launch this one.
The little
I think we should do a comparison.
I think the little one's going to go further than this.
Really?
Right.
If it does, we have done something drastically wrong.
Well, we got to hook up all the wires first. Yeah.
Okay. That's no fun. That's no fun.
Well, the power won't have any. Well, we could test the relays if you want to.
Nah.
The clickety click, the click click.
Nah. Okay. I'm looking for wire number H1.
H1 goes to...
H1 goes to one side of the resistors only.
Okay, that's this guy. This is H1 right here.
Correct. One side of the resistor spring is H1, which ties to our common of the discharge.
I need those right on the end of the table.
Side.
Thank you.
Actually, it attaches right to here.
Okay.
So, do we dare just do...
We can cut that down to anything you want.
I like having this extra space right here.
Okay. Shoot, I packed the
Is that where I want to be? That's exactly where I want to be. Okay. So.
Okay. Starts here.
You're going to put a blue terminal or a yellow terminal?
Yellow. It'll be the same terminal that you put on that
Yellow or blue?
Blue's fine.
Okay.
Good. I bet there's a special tool for this. Like specifically for stripping wire this
coax cable stripper.
Yeah, maybe.
I bet you.
But a knife works.
I bet you that Boden dude's got some in his tool bag. Have you ever seen it? Like, I saw this video one time. He emptied out like his backpack. He had everything.
That's my backpack, not my tool bag.
Well, same sort of thing.
And actually, yeah, we do have coax strippers. You just clip it on. It's like this, and you just like spin it around.
Like
yeah.
I got H4. Bingo.
What?
Get it? H1, H4.
Oh, geez.
Bingo.
Bruce, your jokes are just...
I was going to go with an H1N1 joke, but, you know.
H1N1?
It's a flu. It's a virus.
Yeah, there you go. I get it.
Yeah.
Something.
Cool.
It's too late for jokes, I think.
Dude, it isn't even midnight yet.
I know, but
compared to the last
it's like 2,100 hours.
The last couple times you were working on these projects, it was like midnight.
Maybe because you closed the door and I can't look outside and go, There's life out there!
It feels like midnight.
We're all alone in this universe. Therefore, it's late.
Oh, man.
We agree that it is this time in here.
Oh, man.
I'm gonna need my shrink tubing too, if we want to make.
Yeah, you don't have any though, do you?
I do, and it will work.
Oh.
It just I don't have the final piece, so we'll have to disassemble it to make it pretty tomorrow.
Oh, it's gonna have to come apart again anyway.
Yeah.
I got to redo all the tables. The big plates have to come off and get done properly.
Okay. Anyways,
can you put the tubing on?
I can put the tubing on, and then the other tubing goes over the top of the whole thing, like this. You see how there's a little chunk,
right?
And then then it kind of grows,
right?
That's
sweet. That's
That's the way because it reinforces it.
So you can do it. Chris can do it for you at some other late point in time. You want to try stripping that wire with different cutters?
No, this is fine. It's just thick insulation. I'm good.
Now Bill's gonna make the wires pretty. I got to go and take apart the structure and redo all that.
Right.
There's going to be 80/20 involved. There's going to be a whole new mount for the big contactor. I tend to avoid black spray paint with high voltage stuff. It doesn't matter. It's black.
Black spray
You don't
paint
paint anything high voltage. You want to bet? Made that mistake. Painted a Tesla coil secondary black.
Okay.
Looked good as hell, didn't it?
Oh, it looked awesome, and the carbon tracking was beautiful when it started to glow down the side. Yeah, that was. No, we don't paint high voltage gear black.
Can I have the other crimpers? These are fine, but the other ones give you a nice firm bond. I'm picky. What can I say? Did you find that shrink too?
Yeah, it's really terrifying how often when I tell people these things that I actually have a personal failure to base why I'm telling them that on, because I've done all the stupid shit and made so many mistakes.
There's some scissors. Yeah, scissors are in the tool room.
I'm on it.
But I need you here.
What do you want?
I'm just.
Do you need scissors?
Yes. So we're going like that.
Yep.
That's your.
Yep.
That's your end right there on that.
You can back it out.
Back it out like that. Well, I'm gonna trim that. That's no problem.
Yeah, correct.
But that's our end probably.
Yes,
or
correct.
You want it more like that angle?
Let's put it this way. Yeah.
Okay.
Yeah, it looks sweet like that.
It'll be right on top of those other terminals.
Not a problem. We'll take the other ones because they'll be smaller and bend them off the side.
Okay.
This one goes to here.
You just got to get the orientation.
Jeez, I'm gonna have to start. These are big, beefy wires.
Yo.
I'm really surprised you guys.
When you take apart a $5 million machine, you save the wire. They use good stuff. That wire's vintage too. That wire goes back to the 60s.
Really, it's nice.
It came out of a 60 kilowatt General Electric television transmitter.
This is what they used?
No, sorry. That was a 1962 transmitter. It was, I want to say it was a 100 kilowatt. It might have been a 75 kilowatt transmitter. It was a big TV transmitter.
I need a yellow.
So this was the.
It was the smaller of our two big.
This was the plate power supply wire.
I have no idea. I have no idea what specific function it did, but I know it came out of a General Electric television transmitter that was made in 1962 and had an output power of either 75 or 100 kilowatts.
Well, the highest voltage is going to be the tube.
Oh, that wasn't the big high voltage wire. And
really?
Yeah, and it had klystrons.
Oh.
It had 4 klystrons.
Oh, yeah. Wow.
And that was the little transmitter. The big one was a Harris 120UX, which was a 120 kilowatt television transmitter. That was a big son of a bitch. That filled our big truck to move it.
Stand by on that.
Wow.
Yeah, a lot of the parts that we use today came out of those 2 transmitters.
Good stuff.
I would like to get more television transmitters donated. We use them a lot for parts.
Real good stuff.
The contactor right here, this one, came out of the GE transmitter.
Yeah, you had 3 or 4 of those.
Yeah, we've held there's 3 in this room.
I guess we got to keep our eyes open because the FCC is trying to talk TV people into giving up their FCC bands.
Well, we got a lot of transmitters when everybody went digital because they couldn't use these old analog transmitters anymore.
Even digital, the FCC's trying to give them to.
Yeah, but digital transmitters are no fun to work on. You can't do anything with them. You can't just because it's a computer. I mean, there's.
But
I bet there's something still there. Man.
Oh, but the RF
there's some parts.
probably less too.
Yeah, Yeah, they output a lot less power. They're a lot smaller. We've got a digital transmitter, and the whole thing fits in one rack. Like that Harris unit was like a dozen racks, and they're double width racks. So I mean that's big stuff. The GE was big double width racks, and it was like half a dozen of those.
Well, you only buy it once.
That's how they look at it, and you know you got to understand these people that buy these machines. They cost millions of dollars. They put it in a special building. It's got a huge power supply that goes with it.
7 years, and so after 7 years, they're free and clear.
Yeah. You know, that's how it goes.
The big power transformers for Gemini and for Zeus all came out of television transmitters.
Those were the line trans?
Yeah.
Oh.
Yeah. That pair of big giant...
3 of them.
Yeah, 4.
4 of them?
4.
Why would they use 4 of them?
I don't know, but they used 4.
Just in case one goes up. I don't know.
It might be 2 redundant pairs, actually.
Well, I saw a rectifier stack in high voltage, 3-phase rectifier stack.
That came out of one of the transmitter cabinets.
Right, that would be for the plate power supply.
Yeah.
Which would be 30 kV or something, maybe.
Yeah, it's about that. I'd like to get that big rectifier stack mounted to a wall and hooked up and properly wired in and used.
What are you going to do with it?
Big fucking DC power supply, dude. I mean, it's just cool.
It's probably only good for 5 amps.
So? 5 amps at 50,000 volts is pretty beefy shit.
Okay, correct.
Just got you there.
Bill, what do we do with this?
He doesn't know.
Okay, you want to run the cable to the position you want and try and match the orientation. Okay, then cramp it.
But I mean, what do we do with
crimp it?
You're going to crank it down, then we're going to rip it or pull it back another about ½ inch. Then that goes over, and then when we're done,
so I should watch you.
Then this will go over, over that, to there.
Yep.
And then when we're done, the final piece actually goes from here.
So I'm going to get everything set, pull it back 1/4 inch or 3/8,
something like that.
Do an initial heat shrink to secure it physically.
Yep.
Perfect.
So we have a little bit of robustness in our building.
It's going to be also much fun watching the wiring errors that you made when you put it together.
Oh yeah. It's all your fault, Bruce. All your fault. You misguided me.
You didn't have the drawings when you were wiring it. That was the problem.
I'm a genius. A genius.
I don't see how you guys can even do that.
I'm a genius.
No roadmap.
Still a genius.
You just get the picture in your head. It's not a complicated system.
Yeah. The part I did today was more just grunt, like sit, put your head down and work.
Yeah. There was only 12 connections.
Right. Yeah.
Okay. Gotcha.
Well, they were straightforward.
And this is not 18 gauge wire, dude.
Okay.
It's closer to 12.
Yeah. It's fine. It's good stuff.
It's like it could be clean.
And you have more of this?
Not much.
This shielded.
Yeah, what we have left is in the tub over there. Unless there's more in high voltage, I don't know.
Now, really, I would think that for well, yeah, you saw the original install. The outer shield was a drain wire going back to safety frame ground. We're not doing that here.
We're just using this as the insulated for the insulation.
Right. Which gives us really good insulation, but it doesn't actually ground the outer.
Well, we don't have a shielding issue. That's the thing. We just have a voltage issue.
Yeah. Okay, you need scissors yet?
Yeah. Yeah. Did you get those?
Oh, we're waiting on Chris to get those. Right? He probably knows where they're kept.
And he's about to give me a knife, and I don't need a knife.
No, there's scissors. There's Fiskar scissors on my Gerber.
Oh, come on, give me a break.
No, they're actually pretty good.
So you
is it something I need to fold out? Or
yeah, they're inside. Here, I'll show you. Give me a second.
Fruits and high voltage.
Hold on to something else. Who's manning the camera? The live stream camera.
The live stream camera's fine, but we can put Jabroni or Marcus on it.
How many people are watching the live stream right now? 7?
8?
Who cares?
3 of them are Sparky?
Yeah. They're watching, we're happy.
And it's recording, so that's what's really cool.
It's recording?
It records everything for 2 or 3 days.
You're kidding me.
Nope. Although we burn like it records it to the internet. We burn like a meg upload on our live stream.
Really?
It doesn't make sense to me. I've run like Ustream and Stickcam and stuff on a 768K upload DSL line.
And we're burning
a meg.
Wow.
I don't know what. I think something's not quite right.
Well, we should tweak that. If we're gonna burn a meg, I want to be like freaking high def.
High def, like 1080p output.
But we're shooting this on like 90s vintage SD cameras.
I know. That's why I'm like, mega. No, something's wrong. Something is seriously wrong.
Well, you should be tweaking that.
And you're using the host storage to store days worth of it?
Yeah.
And then what are you doing with it? Just overwrite?
Yep, pretty much. It's what they do. That's how they roll. Now I'm done with your your equipment.
My Fiskars scissors.
Oh shoot, I lied.
Do you need them?
Yeah, I do. I need to trim this down. Thank you.
Might I need my high voltage probe again?
That'd probably be a good idea. We want to be able to verify numbers and stuff.
Right.
You got it with you?
Yeah, I think it's in my truck.
Okay.
You always sound so positive when you say things like that.
Heck yeah.
That was nice and warm. I love these things because I inherently always burn myself with them. And I was once training a guy, and I'm like, make sure not to burn yourself on this. And I walk away, and he burns himself, and he's like, yeah, I burnt myself. I'm like, are you stupid? Psst, and I burnt myself when I was chewing him out.
We used to have a pretty much standard injury in my printing class, and we called it the bacon scream problem, because we had.
Did anyone smell bacon?
No, we had this damn thing. It was a shrink wrapper.
Okay.
And which is basically a roll of, it looks like saran wrap, but it's shrink wrap, and it works like heat shrink, okay?
Yeah.
And it's a plate with a roll, and you set whatever you want to shrink wrap, which for us was always stacks of business cards or paper and shit, because it's a print shop. And you set your thing on there, you turn on the heating pad, and it's just a hot plate, okay? And you pull your shrink wrap over, and you flip it around, and as it touches, it shrinks it. Well, you've got this big damn plate that's about the size of the top of this that's hot. And it's not like, set you on fire hot, but it's like a stove hot.
It's a bad day hot.
Yeah. And one of the rules, and you'll see this around the shop, is anywhere you have a workshop, print shop, any kind of shop, gravity actually increases by about 5%. And you can tell this because idiots, look, right here, idiots have to lean on shit all the time. Everybody's got just, hey man, what's going on? Well, people would walk up to this damn machine, which sat right on the end of the table, and it was at like this height. It was at like table height. So people would just walk up and be like, okay, and it was off 90% of the time. But when it was on, people would walk up, and you'd have the bacon scream theory, because what you'd hear would be they'd walk up and they'd lean. Nobody ever checks it first. They'd just walk up and go, and you'd hear, and then they yank their hand off and start writing. And it'd be cool because it'd leave like a skin print of hand on the thing, because they put their, imagine putting your full body weight on a stove. So yeah, bacon scream theory. Fun times. Are we clean yet? Is it good?
We'll be in a couple of seconds.
Yeah. All right, time is 2,200 hours.
It feels like 2,400 hours.
Yeah.
It's definitely a thing.
We're not using this gigantic wire next time.
Well, then we have a demarcation.
This stuff should have been saved for the 15 kV stuff, Chris.
We'll use it for 15 kV stuff.
Okay.
We good?
Sure.
Plug me in.
We're gonna do the charge and discharge first.
Okay.
Actually, we should probably pull the damn coil off.
No, we'll leave the coil on, but we can do some low power charge discharge.
I had to ask specifically that.
Stand by. Contact. Power's on.
Safe. All right. I have the controls.
The meter did not come on.
Can somebody untangle that shit?
Not in a matter of seconds.
Sure, you totally can.
I
It's
think
safe.
it's because you have the controller.
Yeah, it's totally my fault. It's always my fault.
I think it's because the controller is laced through.
Yeah.
Give.
That I
Give
was
that.
waiting for you to take it.
Someone did not wind this, and I am now pieced. And I'm now winding it more.
Right now, Steve is like killing you in his mind.
Steve can kill me in his mind if he wants to.
No, I'm not killing you, I'm helping you.
Oh.
Wrong Steve. I was thinking engineer Steve. He's fanatical about the proper coiling of cables.
Why would he kill me? I'm the one.
You're holding it. It's your fault. Isn't that great how that works? All
Take
right.
a walk.
Tangential liability.
I'm gonna stand back a safe distance. I'm gonna go over here by Aaron. You can tell Aaron's been hanging out here a while. He knows when I back away from some electrical thing, he follows me and stands behind me. Yeah,
It's the bomb squad effect. You see bomb squad guys moving.
I actually have a t-shirt that says, I am a high-energy physicist. If you see me running, try to catch up.
Something more like, if I'm a high-energy physicist, if you see me running, you're not actually seeing me.
Oh, Jabroni's breaking out the big camera.
Okay.
It's dark outside.
Okay, well, we're gonna do low power testing inside until it starts bouncing off the ceiling, and then we'll take it outside.
Cool.
Here, I'm handing you the camera. You're good with it. All right, can we turn the power on?
Just stand by. Give us a millisecond. Somebody give the baby.
They're not.
Thanks.
We're metering. Please stand by.
Standing by.
This is kind of like deja vu, isn't it?
We ready yet? You ready yet?
Standing here, wait.
You ready yet?
This is the first 4,000 volt ring launcher I've ever made.
This is deja vu.
Alright. Deja vu. I'm just like moving
This is where I'm supposed to say, we're supposed to check the wiring before we just power it up, aren't we?
Yeah.
You know, if Thumper works just fine,
we've reached
I
4,000
think this'll
volts,
work just
we're in
fine.
trouble.
We got love.
Now, we have used these capacitors before, but that was in 2001.
We're supposed to check the wiring on this, aren't we?
That's what we're doing right now.
I rang it out in my mind, Bruce.
Huh? Yeah, those are oil filled. Probably fish oil. I know they're PCB free, but beyond that, I don't know the impregnant.
All right.
I know they're pulse rated. They're made by Cornell Dublier. They were made in 1984.
Okay, cell phones off.
Why?
Don't worry, they'll turn themselves off if you get too close.
Oh.
We're gonna start on fire.
All right. Are we ready for
back
relay?
up, then.
Are we ready for breaker on?
Yeah.
All
Right. The circuit breaker on. We're gonna
Everybody
get
ready?
All we're gonna have happen is the meter's gonna turn on.
You wired it. You want to do it? You want me to do it?
I'll do it. You stand by and just look at the meter.
All right. Clear.
You're disabled.
I'm safe.
Meter.
Meter's hot. Meter reads
Voltage.
0.
Okay.
Meter reads 0. Check reads 0.
What do you mean by check?
The fluke on the ground. Everything's at 0.
Shouldn't we tip the fluke up so we can read it from away?
Might be a good idea.
Hey,
Hey,
I
you
got
know
the cool safety
these
glasses
actually have the kickstand.
Bitchin'. Okay.
That's right. All right, we're all good.
As soon as you release the E-stop, we're gonna have the dump relay energized.
Okay, jump relay should energize in 3, 2.
Good.
Okay, I have 1 down, 2 up.
Yep, you're good. So, if you charge just for like 1 second.
I'm going to do 1 second of charging in 3, 2, 1.
Wow.
Something is not right.
This says 193 and that says 0.
Yep.
I believe this.
Yep.
So we have 180 volts on the bank? No, that's a decimal point there.
That's still 1 millivolt per volt, so
Okay.
the capacitor bank's 180 volts.
You should be reading 180.
What's your time constant, Bruce?
There's no time constant.
Well, you're doing RC.
Time isn't really a constant. You see, the way it works is it's acting...
we could take the 2K ohms into the, how many
We've got
microfarads?
200 volts on the thing. You want to get rid of this?
No, we're going to find out what's wrong with our voltage divider.
Alright, I'm going to dump it. Do you want me to dump it?
No, you're right there, because I want to see the voltage.
Okay.
It's
you have
me.
170,
Yep.
so we've got a little...
I want to see what our voltage divider doesn't think there's 170 there.
Wait, no, the voltage you're reading on the meter's off the divider, isn't it?
This is capacitor
Radar,
bank
I got to
voltage.
say
I believe it.
sunglasses in the car.
Okay.
Grab it, please.
So it's
Passenger
reading
seat.
166 volts, not 1.65 volts.
Yeah, it's 160 volts.
Correct.
Okay.
Because we're hooked through the divider.
Okay. You mean
And I
through the
got
caps?
Yeah.
voltage going into my divider. 163 volts.
You're about to make a very expensive mistake, just so you know.
Why?
The low voltage wire on your meter probe is still at 4,000 volts when this is charged, and that wire is not insulated for shit, and it's touching the case. That will explode when you take it up to 4,000 volts.
Yeah.
No, just on the seat. Passenger seat.
We'll clean that up as soon as we get this meter to read.
All right.
Correct. We want to make sure.
Just wanted to mention that one.
Yeah, correct. We want to make sure at least there's some air insulation there. So.
Thank you. They're safety glasses as well.
I don't think my little voltage divider's working, gents.
Do we have a lack of a contact or something?
A lack of a...
You're saying the voltage divider may not be working, not the meter?
Correct.
Okay.
Okay. So there's just a whole bunch of series resistors.
You got that solder joint?
I'm not talking to myself.
I think so, maybe.
See, this is when we need the dramatic music.
There.
Bum, 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 bum.
There's nothing there.
Some slow piano music. If you get 150 volts on a resistor and then on the next one you have nothing, that's screwing bad solder joint.
Yeah. 70. Yeah, there's something here weird. Darn it.
Shit. It's a solder joint machine.
Well,
all right.
73 volts.
Let's put...
Or a bad resistor.
Let's use the fluke meter for testing them.
Sure.
All right. Ready?
Hold on.
What are we doing? What are we doing?
We're going to use the fluke meter for testing. We have to... We've got a bad solder joint on the divider board.
Okay, pull it all the way out. So we can see the top of the stand.
Okay. We believe this meter, but we want to discharge it now, Chris, to give us better insulation on the high voltage measuring.
Stand by. Discharge in 3, 2, 1. Dump banks.
Okay, you're dumping
drop, but it's dumping.
Yeah.
Good.
All right, I'm going to clear the relay in 3,
Hold on, let it go
2.
down.
It's at 0. 1. Okay, the relay's reset, and I heard it.
Good. So it charged and it discharged.
Yes,
Now,
charged and discharged.
good point.
Volts. You want this to be, well, here, loop it.
Yeah.
Like
Sweet.
that, and then you're safe.
Hold on.
All right. You good?
Huh?
You happy there?
Like a pain.
Sure.
Where does that white wire go? Up here?
Correct.
You're a little close here.
That's the exact same.
Yeah, but
Exact
the
same
case
wire.
is what I'm worried about. The wire, I'm not worried. The case gives me a...
That case should be
That
isolated.
case should be isolated, but it's floating.
Correct, and there's no guarantee that it actually is.
It should be all right.
We're in the ballpark.
And we're indoors. We're not going to go very high in voltage. All right,
How high
system.
are you going?
I'm going to go to 100 volts and tap the ring and see what happens. It should just twitter.
Let us
System
know
hot,
tap.
charging to 100 volts.
That should be about 1 second.
Okay, we're charging to 150 volts.
Yeah, I was going to say, we shot it.
Firing in 3, 2, 1.
Nothing.
Nothing happens. Good.
That's true. The
It
big
worked?
ass relay worked.
Yes. All right. Charging. 5 seconds. 1, 2, 3, 4, 5. Puts us at 520 volts. Firing in 3, 2, 1. It works. It does exactly what it's supposed to do.
15 volts on the bank.
Okay. Discharging and setting to 0.
Okay. So we pull the voltage divider out now?
Oh.
Oh, let's take it up to a kilovolt.
Exactly. We got to experiment.
Charging to 1. Now remember, this is going to go up logarithmically. So there's a big difference between 1,000 volts and 500 volts. Let's go up to a kilovolt. Charging in 3, 2. $500.
Did you set it off?
I didn't set it off. I stopped charging and the thing went to 0.
We blew the breaker and it went into safety mode.
Wow.
We blew the breaker out.
We tripped the breaker?
I heard something go click.
I heard, yeah, I heard.
And when it clicks, it
Oh,
goes
the
north.
meter turned off, the breaker tripped.
Yeah.
Oh, well. Maybe
We
need
tripped
to-
the breaker.
maybe
Okay.
We need to monitor our line current.
Yeah, do you want to put a thing on that?
Bill's got a thing
We're
right
saved.
here. Bill, can we use your thing?
Absolutely.
You're on more than 15 amps.
Because we only have 2K of resistance.
Remember the resistors. Remember you begged for more resistors.
Hey, Bill.
What?
Paul said, watching, call me if you need help programming the meter. We did about half an hour ago. Thank you. He may need more help. All right.
I need help. Please send doctors.
Please send doctors and caffeine.
Yeah. I need some caffeine. I'm burned
You sure
out.
that's a 15 amp?
I don't care. If that thing fries, I don't give a shit.
No, I was referring to the breaker. Are we sure it's a 15 amp breaker, not a 5 amp breaker? 1.5 amp breaker?
Well, I got a couple 40 ohm. We can put those in. That helped. I can't.
At this time of night, a couple 40s would definitely help.
I'm definitely on board
That's
for
how
that.
we roll. Maybe some Mickeys, St. Ides. 45. All right, ready?
I ain't black. No.
Going hot? All right, you're watching current, we're watching voltage. Charging in 3, 2, headed for 1 kilovolt. If we make it. 200.
That's 35 amps.
What the? What?
34 amps.
600, 700.
34 amps. Why is that 34 amps?
800.
You can't draw 34
Popped
amps.
it again at
Pop
800.
the damn thing.
We're drawing 34 amps.
You can draw 40 amps from a 20 amp breaker.
Yeah, but we're
It squeaked. Hey, you're back.
Yeah. Yeah, been at school.
Yeah.
Oh, yeah.
Great.
I'm thinking
Up
there's-
until the point when the tricks, the safety system comes in like a goddamn crowbar and it goes to 0.
I feel the line where it's warm.
You think? It's a light bit toasty.
Okay.
It's not hot, but it's warm.
What is that, 18.3?
All right, system
What's
safety.
the voltage today, Mr. Boden?
Voltage is
Voltage is
at
0.
squat.
I'm thinking we got a bad rectifier.
You think?
What? Bad rectifier? You're saying that's why it's drawing 30? You sure it's not the resistant bank isn't large enough to slow
You want to put your tongue on it? They're cold.
Yeah, the resistors are totally cold.
Oh.
Gotta be, yeah, it's a
Well, that would-
thought then.
No. Bruce, put your hand.
This one will be the warmest one.
Put your hand
Yeah.
here.
Yeah.
Now put your hand here.
It's cold.
Yeah, they're not, I mean,
The resistors aren't doing
burning hot.
No, we got a problem with the power supply. The doubler.
How the hell are we pulling? Even the Mott on its own should current limit itself a tiny little bit to where, I can see a Mott drawing like 25 amps, but
It's warm.
near 40 is asking a lot of a Mott.
Doubler.
I don't know, when you start charging, I can hear something humming in there.
Yeah, it's a
That's the
transformer.
microwave transformer.
Relays.
I'm glad everyone responded, but nobody waited for either person to say it, so it was all just.
Trying to confuse Aaron.
It's totally the transformer.
You think
That
because it's hot as
side was
Hades?
a little warm, but it's not 35 amp warm.
$40 and
The plastic impact
You can
rated.
fish with them at night too.
Yeah, they're polarized. Going hot, clear, system hot. Okay, Armin.
Everybody slowly back up.
We got metering. We're armed. Charging. Headed for a kilovolt. Not expecting to get there.
Whoa.
9 amps.
9 amps, but what's making bad noises now?
Just a relay.
And you're
Got
dry.
negative voltage on the thing.
Yeah, but you got 900 volts instantly on the bank.
Oh,
Okay, that's fine.
what did you do?
We took a diode out.
So we're backfeeding the power into the
That's
tank.
charging way too fast. So you know.
Okay.
All right, we're at a kilovolt and change.
What are you gonna do?
Everyone back the hell up.
3, 2. Hang on a minute. 3, 2.
Holy crap, man.
That was a good, what?
Fired faster than the
15 feet.
Contacts did not weld open.
But it wasn't.
That was a nice colored art, dude.
Yeah, that was. Everything's working like it should. All right. Bruce, what do you want to do?
Put a different diode in.
Yeah? All right.
Actually, we should call Paul.
Hey, Paul, give me a call right now.
He can't hear you.
Thumbs up.
Huh?
He can't hear you through that.
Somebody write it down and then put it in front of the...
Yeah. Paul,
I have him on my phone, guys.
Whoa, we do? Okay. No!
Help us, I think everybody's about to die.
I don't know that I'd call Paul if that was the situation. He's a good guy, but at the same time, he's on the other side of the state.
All right, I'm going to take this up to 1,500.
Frightening.
We'll do 1,500? Now it's slower, but...
1,500
Yeah, you're there.
1,500 volts in 3,
Jesus.
2. At 1,500, we tap the ceiling.
Yeah.
I like the arc too.
Yeah. It scares me every time we did it.
He must know it's you because he's ignoring.
I saw the plating come off the plat.
All right, ready?
No.
2 kilovolts.
Hold on, I gotta get back here. I don't want to be anywhere near that thing.
I want to see the arc.
Aaron, you
on
did
the
good human
contact.
shield.
All right. Aaron, are you rolling?
Yep.
2 kilovolts.
I'm stuck by a forklift.
I'm using the forklift as shielding.
Nah. It's 2 kilovolts. 3, 2.
Okay,
Yeah, that definitely hits the ceiling.
we lost the energy into the ceiling on that one. You want to touch it?
It's not hot.
Is it not? Okay, good. Cool.
Okay, 2 kilovolts again.
Get a picture of
But
the
you want
arc.
to take it outside and see?
Aaron, you want to come over on this side?
We're losing
Sorry.
time, man.
Yeah, look, get the hell out of the way.
It looks good.
Oh, okay. Sorry. I thought you meant the trajectory.
No.
2 kilovolts. 3, 2. Give me a small hard drive platinum, please.
Oh, we roll it outside, Chris.
What? You're gonna see it in the dark? We're not hitting the roof hard enough to hurt it.
You need a small one?
Yeah, 3.5.
Hard drive platinum. Where's the? No, here.
There's going to be platters on the roof.
They'll be going through the ceiling.
Let's put the big platter on there.
It won't work.
Why?
This is the big platter. You mean like a big 15?
The 13.
It won't work.
Coil's too small.
The coil's too small.
How about we just get a big sheet of aluminum and put on there?
Charging as fast as shit.
3, 2. That is so freaking cool.
I'm going to go with, we're going to get 80 feet at 2K. Yeah? That's at least, what, 25 feet?
Yeah, it's about 25
And it's
feet.
not slowing down by the time it whacks into it. Wow, that was...
Charging!
Whack! Whack!
2 kilovolts. 2, 3, 4. What? 5. 2,500 volts in 3, 2.
Your voltage.
There's dust coming off the roof.
Your voltage. The voltage reading is.
Do you want to go to 3?
After the shot.
At the end of the charging at 2,500, we got negative 1,000 volts on the meter.
Yeah.
So your voltage divider might be working. It's just not working right.
Charging in 3, 2.
I'm thinking it's
Test.
Use caution. Those are glass.
What are glass?
The platters.
No, they're not.
Yeah, they are.
Some are glass, but not all of them. This is aluminum. 2 kilovolts. 3, 2.
Ha! That one went
That's aluminum.
No, it's like hardened glass.
No, this is aluminum.
Okay, that might be glass.
Told ya.
Oh, damn it. I got the safety glasses, Chris.
I've seen glass ones, but never this big. They're always in laptops. That's the first time.
You want to test each one out before you do it?
Well, it's an easy way to tell. I just put it on here.
Well, okay.
This is a glass detector. Charging.
By the way, everybody check yourself for glass.
30 amp charge.
2 kilovolts in 3, 2. That was aluminum.
Yeah.
Oh, it worked.
2 kilovolts. Charging.
Did it work? It literally distorted it, Chris.
Oh yeah.
Yeah.
That's 2 kilovolts.
At 2 kilovolts,
22.
it's reading negative 800.
23. 24. 25.
So one, we probably got it backwards.
26.
Holy shit.
27. 28.
As it slows down, I got a little more frightened.
I'll just stand behind you.
Don't stand behind me.
2,700 volts out of it. 3, 2.
Awesome!
That came down as fast as it went up.
It's not. I think we're approaching the limits of good judgment here.
Yeah, 2,700 volts.
Inside.
Inside, yeah. Even outside, because that thing's going to hit somebody.
Are we sure we're metering this right?
Yeah.
Are we hitting a limit? Well, no, 2,700 volts. It's a doubler. We're getting about 1,200 volts out of the power supply.
Open, yes.
We need a tripler to really...
Did you max it out?
Yeah.
At 27K.
Ready? 3, 2, watch here. I'll dump it to 0 because we still got 30 volts in it. Okay. All right, you ready?
2 minutes.
Huh?
I got 2 minutes left, so.
Okay. Charging. I'm just gonna hold it down. Watch. There's a kilovolt.
And watch the line current.
Okay, let her set. 21, 22, 23.
Let her sit. 3 amps.
24.
3 amps.
25.
3 amps. 3 amps.
26.
3 amps.
Okay.
It's not a
27.
full wave doubler, it's a half wave doubler. So,
27.5.
Check the meter. So the meter's half.
I see that, but I think it's because there's bad
9.
connection in the high voltage.
2,800 volts.
But it is actually.
28.5.
Yeah, let's discharge.
3.
Oh no, it's not discharge that way, it's just discharge the normal way.
Okay, discharging.
Came down in a hurry.
Wow, that crashes. I like that discharge.
That's because our resistor values are too low. But they're okay, they're fine.
Hot?
Damn thing. No, they're not hot.
Well,
2,700 volts.
It's fine.
27.5 in 3, 2, 1. That's science. I'm going to say this is successful. Put it on.
Yeah, that's what it did that.
Hold on. Can I get a shot of that?
Ooh, it even warped this one a little bit. Just a little bit.
Yeah.
Ah.
Nice.
Let's wheel it out in the outside, man.
Is your coil
Do we have any?
And we'll never find them.
Is anything on there?
Yeah.
Oh, you're doing it right now.
Charging
We'll
the
find
short
them.
stack.
Hold on. Let me get the hell out of the way.
It's charging.
Alright.
Yeah.
Yeah.
23. 24.
I'm backing away.
26, 7. 27.
Let's see if I can actually get it to where it lands.
27.5. 1391 indicated in 3, 2.
That would be a problem. Just to throw all of those in the ceiling.
Oh, no, not at all.
And it would have
System safe. Alright, you two take a minute and sort out the meter and then we'll wheel it outside. Once the meter is reading true, we can take it outside, but I need to be able to see, I can't see the fluke meter outside. I need a meter.
How did this start it?
Hang on.
Holy
Focus.
crap.
It's concave.
System safe.
Science, bitches.
Bill and Bruce, fix that meter.
Science!
We need more load.
Well, the cool part is...
Firing in 3, 2. We'd like to thank our sponsor, Rust-Oleum. That's warm. We'd like to thank our awesome sponsor, Rust-Oleum. All right, now let's try a short stack.
Oh,
Oh,
shit.
come on.
Well, some of these are going to be glass.
Those are glass on. Yeah.
Yeah, this will help sort them out.
Yeah, we will know in just a few seconds which ones were glass and which ones weren't. The glass ones won't be affected by the impact. So any that stay behind.
No, it's not that they'll stay behind. They're just going to smash when they hit the floor.
3, 2, 1.
They're all metal.
All right, let's take it outside.
Huh?
Let's take 22:48 hours, and we are moving out into the parking lot.
Yeah, this one's wanting a power cord, yeah.
That's gaffing fail.
You guys got it all now? Man, this is a lot of goofing around. Is this gonna eliminate the whole
Not here, but ugly.
And now we're making a Die Hard commercial.
Why did that guy in the Jeep go, oh my fucking...
All right, are we ready?
Could we strike those lights again?
Why? Just because it's a cool visual?
Yeah.
Get over and get across in the parking lot.
I was gonna get behind it.
Okay, yeah, go get on this side. That'd be cool.
Will we do it?
Yeah, go ahead.
Ready?
Hang on, let me put this away. I'll be back. All right, operational test after wire repair. Time is 22:53 hours.
I think we need to close
System
the garage door.
arm. Charging.
Garage door down, better backdrop.
2 kilovolts on bank. I like that I can read the numbers and I can get away from it now. I got to tell you, being the guy that stands closest to the machine, not always the best part of my job.
What, you don't trust us, careers?
I totally trust you, but there's a reason we do high voltage and not chemistry. I like being able to stand across the room and push a button.
Is it charging slower than I remember?
No, the meter's reading lower than you remember.
Okay.
It's still charging at exactly the same rate, but the meter lies now.
It's actually saying...
It's saying 2400. We know it's actually, by this point, about 2750. 3, 2, 1.
Where'd it go?
Over there.
Wow. It disappeared.
Woo!
Disappeared is right.
Did we delaminate it?
No, actually, I followed it all the way
That
up.
sounded like a piece of tin.
Going with a big one.
All right, hold on, Chris. You got people in the firing line.
So, screw him. I never liked that guy anyway.
It's hot and a dish.
Really?
Hey, keep that.
That's cool.
So most of the energy of flight went into deformation.
Holy cow.
Awesome.
Beautiful.
Huh.
Can we get that quarter-inch plate? We need more power so we can make
Right.
them like spears when they
I'm
go
thinking
off.
an optimum coil and more voltage.
I think more voltage is more than anything.
And an optimum coil. Yeah, the coil is quite
Great, it's not arcing over.
No, we're trying to follow it all the way up. Marcus said he
Oh, it's
saw
not
it.
even human.
Yeah, no kidding.
Alright, you want to go by now? I got 24 indicated.
That's probably top, about top.
Yeah, it's slowing way down. Alright, 3, 2.
Oh, I saw
Oh, shit!
About twice.
Almost on
Twice the building.
Yeah, I followed it. I actually tracked that one.
Did you track it good?
Woo!
In fact, you tilt the lights. No, we don't want to do that. Not a good
No,
idea.
it's fine. And
They would
only
fall before
slightly
they
dish.
tilt.
Fuck you, battery. Fuck you.
Let's try another big one.
Yeah, it looks like a record after many, many years.
Big one and a little one.
It sounds so dirty when you say it like
Hey,
that.
by the way, Bruce, where's Bruce?
No.
Your meter's hooked up backwards.
I
Again.
know. This is experimental. This is
Again.
R&D.
Every time.
It's not a negative.
Every time. we
Fuck
hook
with
it
the
up
R&D
backwards.
department. They'll get mad at you and
I'm just
set them
saying.
up this way on purpose and then not fix
Every time we hook it up backwards. Every damn time.
working. Hey, you know, if I give you a bunch of lines, you can
Chris,
play
after
with
this,
the
got to
acidic
change
too.
battery.
Jeez.
Huh?
After this, got to change battery.
Alright.
It's blinking.
Morning.
Blink, blink,
It just curls
blink.
up that last few, doesn't it?
Yeah.
Because it's topping out.
In,
oh, I know.
yeah, alright. I'm gonna get behind the light so I can see the damn thing.
Alright, fire at will.
Which one's Will?
Yeah, he makes a good will.
3, 2.
Oh shit.
Oh shit, my car. 3, 2,
rolling.
1.
Oh. That was almost perfect. Wow.
Alright, jumping bang. Put a, the big ones fly higher.
Yeah, because they don't dish.
Well,
this one's actually good.
Put that back on there, we'll do that again.
Chris, I wasn't exactly listening. What's my shot?
Just the crowd. And you should be able to track the thing for the whole flight pretty easy. Don't track it though, stay on the crowd.
Yeah. Right. Rolling.
Go ahead.
Aaron, rolling?
Yep.
3, 2, 1. Seems to be the consistent shot. In 3, 2, 1. Aaron, you can just stay rolling.
Yeah, I am.
Excellent.
So I guess I would call that a success.
That is absolutely a success. Good job, everyone. Thank you very much.
Hold on.
You want this?
Yeah, I'll take that.
Did I?
Okay. Yeah.
All right, guys. Time is 23:11, and that was a fabulously successful test of another flagship project, the Ring Launcher. We got to give these guys better names than just Mini Thumper and the Ring Launcher, because that's, I don't know. Write in with your suggestions for names. They need project names. So, yeah, Mini Thumper is a resounding success, and the Ring Launcher is a resounding success, and I'm a happy guy, and they're happy guys, and we just did a whole shit ton of work, and that's pretty awesome. So now, we need to focus on lab infrastructure stuff, but this is cool. We got a couple new flagship demos done. They're at the prototype tested working stage. There's a lot of finish work to be done on them, cleaning them up, making them pretty, but you'll see that as it happens. So yeah, there you go. Another big epic captain's blog for all the viewers out there. Get involved. If you're not a member yet, go to thegeekgroup.org and become a member. Okay, get involved, be part of this. We all desperately want nothing more than to share this dream with you guys out there watching these videos. That's why we make the videos. So I'm Chris Boden. You guys have fun. And as always, that's today's Captain's Blog. See you next time.
I learned how to run a machine shop.
Set up an enterprise-level server.
Program 9-foot robots.
Make lightning!
Edit video.
I'm building a radio station.
Light bulb terrarium.
A high-performance electric car.
I'm a CNC geek.
Computer geek!
Robot geek.
Physics geek.
AV geek.
I'm a radio geek.
Craft geek.
Car buff.
No matter what kind of geek you are, we've got a place for you here at the Geek Group. Come join us. We build awesome.
Now, Chris, How are we gonna get this to high voltage?
There's a ramp all the way around.
Oh, that's right. Yeah, I always forget about that ramp.
Side of the building.
Now, really, it's all about making it pretty and tweaking it, but we've got an operational
We're
test.
thinking different top.
Yeah, I wanna experiment with different coils. That's easy
Now,
to do.
I think I'm right, but I'm not certain. If we use a smaller wire and more turns of it, don't we get a larger Gauss effect?
That's where we do research. That's the point.
Okay, so we'll pour.
Get me a couple big Anderson power poles.
Yeah.
All right,
and we'll just. Woo! Yeah.
Cool.
More precise than this. It ain't happening.
That's what you gotta have. It's good.
What you making, Bill? Bruce? You're Mark? Fuck! Ah!